Hello, so today we are going to begin looking at the topic logarithms. But before we look at that topic, we are going to look at the laws of indices, because indices and logarithms are related. Yeah, so laws of indices. Laws of indices. So we are going to look at the laws of indices, and the first law says if you have a number x raised to the power, let's say a number m, and the whole of this thing is being multiplied by another x to the power n, a different power n, the answer you get should be x, one of the x's to the power, the powers are going to add because the bases are the same, so you're going to add the powers m plus n, like that. Okay, then the second law of indices, again, if you have, let's say you've been given x raised to the power m divided by x to the power n, this time around, of course, the bases, these numbers are the same, but since they are dividing, we are going to get one of the x's, and because they are dividing, the indices, the powers are going to subtract, so you have m minus n, like that. The third law of indices is that when you have x, let's say you have x raised to the power m in brackets, or it's being multiplied by n, like this, the answer you're going to get is x, the same x, multiplied by m n. So these powers are multiplying here, or m times n, like that. And so these three laws of indices are called laws of indices, the basic laws. So these three are basic laws of indices. Now from here, from these three basic laws of indices, we can deduce other laws like x to the power 0 is equal to 1. So when you are given a number, let's say x, and when this number has been raised to the power 0, it will always be 1. So any number raised to the power 0 is 1. I repeat, any number raised to the power 0 is 1. A million raised to the power 0 is 1. A billion raised to the power 0 is 1. So there are one exception. So x should not be equal to 0. Yeah. For this to be true, x should not be equal to 0. Okay. Hope that's clear. Number 5, we can deduce another law. Number 5. When you have a number x raised to the negative power, let's say negative m, when you have the base raised to the negative power, what the answer you get, or this is same as, this negative power is going to be a fraction, so it's same as 1 over x to the power m. So this and this are the same. So whenever you're given something in this form, you change it into that form and simplify. And yeah, another exception here, yeah, x should not be equal to 0. Okay, the last law. Let's look at the last law. Number 6. Law number 6. We have, let's say, x raised to the power now is a fraction, let's say m divided by n. When the power is raised to the, when the number is raised, it has a power, which that is a fraction. The down number here, or the denominator of a fraction, symbolizes or denotes the operation to be taken, whether it's a square root, a cube root, a fifth root, and so on. So if this number is a 2, it means you're going to have a square root. So what you have, when you have a number that, let's say the number x raised to the fraction like this is same as the square, the radical. You write the radical, the symbol, the square root symbol like this, which is called the radical. This n is denoting the operation to be taken. So n is here. You're going to put your n here, and x here. Then the m is going to be here, and this is same as, again you can write it like this, they are just the same, n x raised this to the power m. So this is the same as that, is the same as that. Okay. Yeah, so these are the laws of indices. Now we can look at an example. Let's look at an example. Yeah. Find the value of a, find the value of a 100 to the power 3/2 b 32 to the power -2 over 5. So let's look at the solutions. solutions. Yeah, we'll look at solutions. Solutions. So A, we have 100 raised to the power 3/2. So now this is same as, or this will imply that because you have a base which is 100 and it has been raised to the power 3/2, which is a fraction. So a 2, because a 2 is symbolizing that you are going to have a square root. So you are going to have 100 here. If you want, you can write a 2 in here, but it's not necessary because this is just, we know that a 2 is always symbolizes the square root. So we are going to say the square root of 100 in brackets, or even you can write there, but even in brackets, this one to the power 3. So this is going to be equal to, so a square root of 100, the square root means you are being asked to find the number that is the number that is a small number in such a way that when you multiply, when that number is multiplied by itself twice, you are going to get 100. So the square root of 100 is 10. Remember, everything is being raised to the power 3. So you have square root of that. I mean, the square root of 100 being 10. 10 to the power 3. Power 3 means 10 times 10 times 10. It's not 10 times 3. So 10 times 10 times 10 is 1,000. Is 1,000. Like this. Yeah. It's 1,000. So this is the answer. Okay, let's look at B. B, we have 32 raised to the power negative 3 in negative 2 over 5. So the rule is that, so here there are two rules we are supposed to apply. One, we have this. We're going to apply this rule here, where we have a negative power, and also we are going to apply this law here, or this rule here. So when you have a negative power, actually we said symbolizes that this negative symbolizes a fraction. So you are going to have 1 over 32. Now, because this powers, the negative powers has become a fraction, we are going to have 2 to the power 2 over 5, like that. the power 2 over 5, like that. So this will imply that you're going to have 1 over, so we said the denominator on the power symbolizes the operation you're going to do to this, or the radical, the type of a radical you're going to have. So we are going to have a radical that 32 inside. This 5 is going to come here, so meaning you are finding the 5th root of 32. And when you are talking about the 5th root, we are talking about a number or an integer such that when that integer is multiplied by itself 5 times, you are going to get 32. I repeat, this is a 5th root, and when you have been asked to find a 5th root of a number, it means you've been asked to find an integer such that when that integer is multiplied by itself 5 times, you should get 32. So this 5 is here, then we have the 2. 2 is going to be outside there, like this. So we're going to have 1 over, so we are looking for an integer such that when that integer multiplies itself 5 times, we get 32. That integer is 2, but remember everything here is being raised to the power 2, so you have that 2 squared is 4, like that.